Hello, and welcome to MBAO 202, MainView AutoOPERATOR Performance and EXECS. This is Part 3. MBAO 202 is the fifth in an 8-part series of courses covering MainView AutoOPERATOR. What is an exec in the context of AutoOPERATOR? Well, an exec can either be a C-list or a REX program, and what it does is it extends the capability of the rules. One thing you might want to do from a rule is just to run an exec. So when a rule invokes an exec, it runs asynchronously from the rule. So you can't assume that the rule will process either before or after the exec completes. When you do invoke an exec from a rule, all of the event variables will be passed to the exec. You also, from the exec, have the ability to issue AutoOPERATOR commands. So we can generate WTOs, WTORs, we can log messages, we can issue sysprog services commands, and many other things. If you want to see the full listing of IMF exec statements, refer to the MainView AutoOPERATOR Advanced Automation Guide. AutoOPERATOR provides a facility to help with the management of execs. From the exec management display, we get a list of all of the execs that are defined to AutoOPERATOR, and they'll either be in enabled, meaning they're eligible to run, or disabled status, which says they are not eligible to run. Now, from this display, we do have the ability to change that state using the E for enable or the D for disable commands. If you want to view the contents of an exec, use the B for browse command. If you actually want to execute the exec from here manually, you would select it with the X command, or if you want to do some interactive testing, you can use the T command. So let's take a closer look at these. If we page to the right using the PF11 key, you'll see the number of times the execs were scheduled or executed, as well as information about the CPU they consumed. If we expand the display using the PF5 key, the display will be filtered to just list the execs that are active in the system. Here we'll see the exec names as well as the CPU usage used by those execs. If you select an exec for execution using the X line command, you'll see a listing of the exec code here. When you're ready, you will go ahead and press enter, and that will execute the exec. If you do not want to execute the exec, do a PF3. Once you've run the exec, you can look in the BBI journal, and you'll see the exec that was executed as well as the params that were passed. If I select an exec with a T statement, it'll provide me with an interactive debugging facility like this. Using this tool, I can set conditional breakpoints, and we can display variables of live statements. We can do continues, we can set steps, all kinds of nice things to do some interactive debugging. Although AutoOPERATOR supports both REX and CLIST for command processing, REX is the preferred alternative. It's simply a more efficient interpreter, and it's a more efficient and robust language. So what you're doing is you're getting something that runs better, and it takes fewer lines of code to write it. AutoOPERATOR does support the tokenized REX compile, but not the full load module compiles. AutoOPERATOR provides the capability to run execs in batch. Here's a sample of the JCL that you would use. You simply call the program AO sub X, and then you pass it the param, which would be the exec, as well as any params you want to pass to the exec. One additional keyword you need to have in your param statement is SS, and then specify the BBISS for the AO address space. There are additional params you can specify, however, they aren't used very frequently. Wait with a yes is required if you want to get a return code from the REX. OSPI, or Open Systems Procedural Interface, is a nice way to get into applications that don't have any kind of a real API. So it's an extension to REX or CLIST, whichever way you're coding. And what it does is it allows you to log onto a VTAM application and gather screening commands to build an exec. It is fully supported in the exec testing facility, which is quite nice. The online scripting facility records the keystrokes that you use in a session, and it generates either a REX or a C-list exec. You do need to specify a hotkey to break out of the session. Typically, that is the PF11 key, but you can assign it to a different key if it causes a conflict with the application itself. Now, after you do the breakout using the PF11 key or the alternative key you may have assigned, you can use any of your PF keys, PA keys, clear control type functions to take actions outside of the session. Now I want to walk you through recording a session with the Open Systems Procedural Interface. Now this example is only for illustration purposes. In most cases, you do not need to do this for a CICS command. We can do this a lot easier with AutoOPERATOR execs. So the transaction group GRQP is just something we built at BMC that does a simple CICS MQ action. So before you start your VTAM recording session, you need to know the Apple ID of the application itself, the log mode. Make sure your terminal is a 3270 mod 2, works best. You need a PF key not used by the underlying application, which by default we want to be PF11. We need to have the name of the member. That's going to be the name of the exec that we're going to generate. We, of course, need to know whether we're going to write REX or CList. If you can't use the Apple ID, then we're going to need the ACB and optionally some user data required to log on to VTAM. And that should do it. So when we go into AutoOPERATOR, we can go into the OSPI facility, and here we specify the VTAM Apple ID that we want to log on to. When I hit enter, I'm logged into the CICS, which is what we expected. Now we're ready to record our session. Since this is CICS, we need to use our hotkey to issue the clear screen command in CICS. Then what we're going to do is we're going to invoke the transaction GRQP, and we're going to use the GRQP transaction to pass some data. And then we're going to go ahead and PF3, hit enter to save the transaction, and then log off of VTAM. So if I hit the PF11 key, I can see option 26 in the upper right is my clear key. So I'm going to select option 26, and that'll clear my screen. And now in CICS, I can start my transaction, which is GRQP. So I'll type that in, press enter. And here's the screen that I get for my transaction. So I'm going to go down and I'm going to type in my queue equal to my local queue name is. And then I'll set this. Then I put my sample message in, and I can go ahead at this point and I can press PF3 to terminate my session and enter. And then I can type in CESF to log off of CICS. After you're done scripting your session, it may be necessary to go in and modify the logic of the exec. Typically, things you might do are add if then else logic or do groups, depending on really what you need your application to be doing. Also a good idea to add error checking to ensure that your commands are successful. You can use generic execs from rules, or you can use other execs with parameters. So some instances where you might want to do that is open in a problem ticket. You may have one exec that does it, and then you pass parameters for the description, application name, so on and so forth. So here's an example of the exec that gets generated from our CICS session. And you can see they're all a bunch of IMF exec statements, and you could add your logic in here with if, then, else, and do groups as necessary. And here's the rest of the exec. AutoOPERATOR also has a facility called AO Anywhere, and AO Anywhere is an application programming interface that gives access to the MainView AutoOPERATOR functions. It also gives you a TSO command line interface, and you can run it inside of an exec or a TSO C-list. We also have the ability to run under a NetView exec. These functions can operate locally on a BBISS running on the same system, or we can route them to remote systems via XCF.
So here's an example of an exec running an AO exec statement. You can see that on line 700. And that concludes MVAO 202 Part 3.